Hey guys, welcome back to another episode of Simuleo. So, what are we doing today? Well, yesterday we got the tree drawn. It took some time, but we finally got it done. So let's go ahead and show that. CD Projects, Simuleos, SciVL. Wait, wrong one. Sorry. SciVL. And then we're going to run SciVL dash S and... Hey, Dirtface Dave, what's up? Dash S and Traverse. There we go. Now we have our tree. It is any type of balanced tree, it will draw pretty well. Okay, I mean, we haven't tried like crazy cases or anything like that, but for the most part it draws them okay. What I want to do is change this one real quick. So CD Projects, and let's go into SciVL, and then what I want to do is go into where do I want to go into? VI source distributions, where we keep all the data here, and let me go down into Traverse par and change the numbers here a little bit. So row number we're going to change to 2, and child number we're going to probably keep at 3. That's okay. And what do we want to do? We want to change the radius back to 0.1. Go over here, make that, run it again, and we should have a simple tree to work with from here on. So let's do Traverse. Yeah, I think this is a simple enough tree to work with for now. We can make it more complicated as we go along, but I think this is good enough. So what we want to do now is show the difference between depth first and breadth first search. Now, the way we need to do this is by some sort of animation or visualization. The problem is I haven't currently worked into my my visualization software the ability to change color with time, so it's something we need to do, but it shouldn't be so bad, you know? So basically what we want to do is run through and do our depth first search. And every time we do a depth first search, I just want to change the color of this guy for a time step, then this guy, then this guy, then this guy, then this guy, so on and so forth. Like, basically change the color for about a second or so, and then go back through, if that makes sense. So just show the order in which we're traversing the tree. That's all I really wanted to do for now, so we'll see how it goes. So first thing we need to do is add in the ability to change color with time. Now, the nice thing is that we already have something that kind of sort of does that, just in a little bit of a weird way. So let me go into VI source and shape functions. We have this thing called move vertex. Now, move vertex basically takes a shape and translates it some distance, right? So the issue here is that when we do this, right, we can move the vertex, a certain distance or whatever, but the way that we have the vertices and the indices kind of held together, basically we're sending in a virtual array object, or VAO is what it's called. I think it's virtual video array object. I'm not sure. I think it's virtual. And this object has both the colors and the location of all the vertices kind of put together at the same point. So for example, if we go down to, let's see, any of these guys, let's go down here to the rectangle, let's say. We have rect.vertices 0, 1, 2, and then we have color, color, color. Then 6, 7, 8, and then color, color, color. And then 12, 13, 14, color, color, color. So we have the color of each of the vertices stored in this way. So what we want to do is basically go through and make that move shape function, except this time it's going to be change color. And we just change the color in a very similar way. We'll test that one out, see how it goes, and then we'll basically add a time step for that and go from there. Once we're able to change the colors, it should be relatively straightforward working with what we already have. So again, this might be more of a nitty-gritty coding type of day, so I apologize if it's a little bit rough, but that's how it goes. Hey, I care, and of course, Dirtface Dave, thanks for coming in, guys. If you guys have any questions, comments, concerns, feel free to let me know, and I will totally address them as soon as I see them in chat. So, let's pop over here, and let's say function to change the color of all vertices in a shape. Okay, so we're going to say void, and it's going to be change color, and we're of course going to have to read in a shape, which will be ampersand sh. We need a glm vec3, which will be the color. And I guess we can read it in with an ampersand, why not? And I think we're also going to need... no, I think that's going to be it, because we'll change the whole color shape at the same time. So I think this is okay. So here we say we want to move a particular shape index, if that makes sense. So like we find the vertex location. We want all of the different vertices could be changed at different times. So for example, in our animate circle or something like this, let's see, I'll look for circle. Animate circle, yep, that's totally a function. We go through and we move all the vertices individually. So we go through all the different vertices and we move them individually. But here, because we're going to change the whole color at once, I think it's okay to just do them all at the same time, if that makes sense. So what are we going to do? Basically, what we want to do is we want to say, let's say shape.vertices of index times 6. 6 plus 1, 6 plus 2. Yeah, so basically all we need to do is shape.vertices of index times 6 plus 3, right? So this is going to be the red color. It's going to be equal to color of 0. And then we just have to do yank, paste, paste. So 3, 4, 5. Okay, and so again, in case you guys are not following what we're doing here, the idea is that the virtual array object, which again is the object that we're sending to the GPU for visualization, has positions and then colors. So it's position, color, right? All in the same array. And the idea then is the first 3 elements are the XYZ position, and the next 3 elements are the RGB color. So this means each group for every vertex is 6. So that means we do index times 6. And then we want to get to the color element, so we do plus 3, plus 4, plus 5. Okay, so now we have to do basically what we did up here. We need to copy the virtual array object back to the GPU, or bind it, rather. So basically, it's going to be all of this, and I'll go back through and check to make sure this is correct. Okay, so we say gl bind vertex array, yep, shape.vao, this should be okay. Array buffer vbo, yeah, I think all of this should be okay. So let's go through and write this. Oh, that was not how you write. There we go. And then we go into vi include and shape functions, and we want to change the color. So where is that? Animate line, move vertex, down here. Function to change color of all vertices. Okay, and we're going to say void change color. And I think it was shape ampersand sh, and then glm vec 3. 1 second, 3, 3, there we go, ampersand color. Okay. And this should make, without any big problems, I don't think. Okay, so now it's a simple test. Let's go through, oh, it did have a problem, didn't it? I didn't read an index. Let's go into shape functions. Ind times 6, I'm reading an int ind. That's because what I want is to go through all the indices. So for, int I equals 0, then we'll say I less than shape dot vertices dot size, and then plus plus I, pop down here and here. Change this to an I, and we should be good to go. Make that. Good. Okay, so did that make? No, it probably still didn't, because shape.vertices.size apparently doesn't have a a value, because I'm pretty sure I set it as or it has to be a double. So let's also add in int vnum, which will then be I less than vnum here. Vnum, which I think is just shape.vnum, so I think it should be okay. And then we go into vi source include. Wait, what am I doing? Source include, that's not a thing. Include shape functions, and we go down here and add in int vnum. Number of vertices. Make. That should make. Good, okay. So let me go into vi source, and let's go into gl setup.cpp. And let me just, oh, sorry. Actually, I want to go into vi include gl setup.cpp. And I'm gonna pop down here and I'm gonna check real quick that I have. Hey, Buttercake, what's up? that I have all of the... I have a thing called vnum. Yes, I do, and it is in shape. Good. So that should be the number of vertices, and it should be okay, I think. Let me check to see how vnum is set up. So this is gonna be in shape functions. Let's go down to vnum. Oh, vi source shape functions. Let's go down to vnum. Here, shape.vnum times 6. Yeah, okay. So this means that the vnum is going to be, yeah, I'm gonna have to change one thing real quick. It should be vnum times 6 down here. I just came up with another way to visualize a tree that's super simple to explain, but I don't know how to implement it in a nice, efficient way. So here's the thing with the tree visualization, guys. As of yesterday, we spent most of the day just trying to figure out how to draw a tree. Actually, we spent most of the past 2 days doing that, and I definitely apologize for doing that, but on the other hand, I think it highlighted an interesting point that there's many ways to draw the tree. Oh, you're right, it's already in shape. Thanks, Dirtface Dave. I didn't think about that for some reason. Not thinking right now. Appreciate it. I'll fix that. But yeah, as far as drawing the tree is concerned, I was thinking about doing another week on just figuring out an appropriate way to draw a like drawing a weird shaped tree. You know, just drawing something that looks funny, and just putting something out there. Because I know there's algorithms to do this. I just hadn't really thought about doing it so soon. But I think, you know, if we're already doing depth first search, I think maybe I'll put on the list of next week's stuff, drawing a tree in a more efficient way or something like that. Okay, since you're right, vnum is already in shape, we'll do vnum here, and we don't have to multiply by 6. So let's just do shape.vnum. Go down here, remove int vnum from here. Go into include shape functions, remove it from here again, because obviously I'm not thinking. And right and quit. Okay. So again, if you guys are interested, I was thinking maybe about spending like an entire week just on drawing trees. Hey, Happy Little Rat, how are you? So I think that's something I'm considering. I'll put it up in the, hey Slayer Darth, I'll put it up in the Twitter poll or something for next week, and we'll go from there. Oh, another thing. I feel like, how do I put this? I feel like I need to do something special for people who have submitted code to the Arcane algorithm archive, and people here who have helped me out with the code so far. I'm just not sure exactly the best way to do that. So I was thinking maybe at the end of my next YouTube video, I just kind of have a list of names of all the people who helped out with the last chapter. I'm not sure. We'll kind of think about that and figure out how to do it from there. Yeah, I'm not sure. Anyway, so let's go into what I want to do. It just made. Oh, I want to change the color or something. Let's go into VI source distributions. .cpp. I'll pop down here. Dance? What do you mean dance? What do I want? Traverse OGL. Yep, this is okay. So we're drawing all of the different shapes right here, and we have all the different shapes. What I want to do, good news. What's the good news, Slayer Darth? We created the tree. We have all of these guys. But what I want to do is change the color of one of them. So let's do par.shapes of. Now I use this section to your readme.md. I learned yesterday at work how to resolve get merge conflicts using vimdiff. Oh, that's super cool. So what I'm going to do real quick is change color of par.shapes, and I'm just going to take element 1, and we're going to change it to color 0, 1, 0, 1, 0, something like this. I think that'll run. Go over here, make that. And it didn't, of course. So let's go down here and say GLM back 3, and we'll call it new color. It's going to be equal to 0, 1, 0. And we're just going to go down here and say it's going to be equal to new color. Make that. Okay, so now I think when we run this, yep, okay, so one of these guys is green. That's all I wanted to see. Great, okay, that's exactly what I want. So now we can very easily change the color. What we need to do now is change it, make it so we can change it with time. So we have this dd. Basically shows you the difference between files. So like if I had a merge conflict in Git, I invoked a get merge tool and have vim diff set as my merge tool. Yep. So it splits Vim into 3 panes to show the local base and remote versions of the file. Yeah. So there's a lot of really good tools in Vim that you should really definitely totally use. Okay, back to this. So, here's what I have so far. We have the ability to grow shapes. We have the ability to change shapes with time. That's really cool. Works very well. Now here's the thing though. How are we gonna do this? Yeah, what we can do is we need to add in like time frames or time steps or something like this. Remote, I believe, is what's currently working on the remote branch. Yeah. Okay, so we need to do multiple things. Let's go and write it down so we don't forget. So I'm gonna go into journal, and we're gonna write this down. I think we can get it all done, if not today, by tomorrow. I don't see any reason it would take any longer than that. And then we can spend Saturday writing the Arcane Algorithm Archive article, and we should be done with this. Okay, so let's go in here. What do we need to do? First of all, we need to, 1, add in time steps for changing color. Let's say delta color. Okay, that's one thing we need to do. 2, we need to animate drawing of tree. 1 second. Tree. And 3, we need to add in, let's say buttons to depth first search and breadth first search. And that's the idea. James doesn't keep merge conflicts because he uses git solo. The only major thing I haven't done in git yet is a git rebase. I have done that, they're a pain. Git like squashing and things like that, it is such a pain. But it's useful. Like for example, if you want to keep a very clean history for a large repository, you really want to make sure that you you squash everything and stuff like that. Okay, so let's talk about how we did the time steps so far. So right now, each of the shapes, go here. Where are we? Shape functions. Yep, here. We have keyframes. We have this ability to add keyframes, okay? Now the thing is, this add keyframes function basically goes in and says, okay, how do I put this? We have some sort of param par, some sort of shape, and we have a start time and end time. I think with git rebase, it rewrites the project history to put your latest commits to the top of the branch, right? You can do a lot of different things with rebase. It basically goes through and modifies your commit history to do whatever you want it to be. Is that you really need, but can be super used as filter branch? Yeah, I haven't used that one. Okay, so what I want to do is I want to show what this does. So if we go into VI include or source shape functions, go do keyframes. Basically the way I have this set is it adds a keyframe to start and end drawing at a particular time. Now, here's the thing. This means that par only has par start time and, some sort of start and par start time and par end start. Oh my gosh. Every shape has a start time and end time for drawing. This is great if we want to do simple animation. However, chances are we want to do something a little bit more complicated, or we could do something a little bit more complicated. So the question is, do we want to create a vector of all the different keyframes, and at these keyframes, like for example, if we go into animate circle, basically we say, where are we? Animate circle is there. We say, what is it? With start time and end time. Start time. Here it is. Shape.start time, shape.end time, shape.start time, shape.end time, so on and so forth. We probably need a general way to do this. Let's go back up. But basically the idea is we have some sort of total time of drawing, a current time, and that current time is dependent on, your start time and end time, right? And your total time is also dependent on your start time and end time. And basically the idea is we just kind of make the circle grow in size. Now the issue here is that this isn't really general. It's only for like growing shapes and stuff like that. We can't do anything really complicated. What I want to do now though just so that we kind of have an idea of how to move from here before making it more complicated, is just add another keyframe for changing color. And it's just going to be a vector of all the different color keyframes. So basically, if we hit one of these keyframes, we'll just change the color. And that's kind of the way I want it set for now. So we have simple animations that we can do, and different color keyframes to go from there. And I think that's how I want to do it. So let's go to vi source, or I'm sorry, include, and let's do gl setup.h and go from there. Let me see, what am I missing in chat? The git command to run a grep search on commit messages. Yeah, I think I know of this one, but I don't. Yeah, I'm not sure. I used it recently. I made a Twitch bot and accidentally committed my Twitch auth key. Ooh, I didn't realize for a few commits before I could push it to GitHub. I had to get rid of that, so I ran filter branch and removed the key in every commit. Yep, that's very good. I can actually see why you'd want to use filter branch. Might use it in the future. There's also git short log sn, which lists all of the committers on a Git project, ranked by most number of commits. I should look into filter branch. Oh, one thing I want to point out. Okay, there's a lot of tools that we use all the time that I think a lot of people don't know about, but obviously as people who have been doing a lot of programming recently, we know about a good bit. So this would be like, for example, GitHub and version control, or for example, make files, or things like this, you know? These are things that people probably need to know in order to do basic programming, especially in a compiled language like C++. However, currently, I mean, yeah, there are definitely videos out there that teach you this kind of stuff, but I was wondering if you guys wanted to do videos on this too. So like, we could obviously do videos on algorithm, but I think at some point, maybe it's worthwhile to take a step back and just teach basics, you know, like make, git, things like this, so that when people want to use the archive, for example, or maybe use the scientific visualization library that I'm using right now, they understand how it works, and they can, for example, with Git, they can then submit pull requests easier or something like this. So we have kind of all the information they need to continue in one place. I'm kind of a big fan of the idea of going through like all the Git functions and stuff like that. I just haven't really thought of the best way to make a video on it. So at some point I might still make, you know, I might weave into the weekly videos on weeks where we can't finish an algorithm on time, stuff that's rather straightforward. Not rather straightforward, but is computer sciencey in that people need it, but it's not really an algorithm, if that makes sense. Yeah, that was one. I already have a script written for how to VI, and I really want to get that one out. So I'm thinking maybe once a month or something like that, I'll take some time to go through some simple stuff like that. In fact, maybe I'll do that how to VI thing next time, so that we have more time to work on another algorithm, and we can kind of do multiple algorithms. Like, we can have multiple algorithms backed up. So just in case we can't meet the weekly deadline, we can at the very least have something out for that week, you know? And I think that's might be a good way to do it. Okay, struct shape. We have start time and end time, but what I want to do is the following. This is going to look really nasty. std vector of std chrono high resolution clock. Let's do time point. That's chalk clock. Time point. And we will say color. Color keyframes. Okay, so this should be, I mean, it should make no problem. Unless I misspelled something. Okay, so this is going to be all the different color keyframes we have. So now what I need to do, a Vim tutorial sounds like something very, very time consuming, because you have to start by explaining the very basics, like what normal and insert modes are. Those are things people aren't used to. And then there are a million things you could explain. Yeah, this is true. However, doing the basics, like here's what I was thinking. Kind of going through all of the basics that people don't know about VI when they use it for the first time. So obviously we go into insert mode, normal mode, and command mode, or whatever the command's called, the command line utility and stuff like that. Vimcasts. Why did you not cover XYZ? Yeah, but that's the thing. Like, we could just do like Vim Saga or something like that, and we could just say, hey, here's the first part, here's how to get you started, and stuff like that. I then kind of wanted to go through and do a very quick Vim Golf with everyone, because Vim Golf is like one of the easiest ways to learn Vim. I don't know if you've heard of it before. You just go here, you go just Vim Golf. I'm sure you'll find it. It's pretty cool. Basically, you try to get a task done with the least number of characters possible. So I like it a good bit. What is Vim casts? Casts. Free screencasts. Learn essential Vim skills. Oh, I see. I didn't realize there would be so much information about Vim. I mean, fine, fair enough. Like, it's quite good. Okay, so again, Vim Golf is one of those ways that really teaches you how to use Vim quite well. So let's go to source shape functions. And let me see, what do we have? So we have draw shapes. But let me go down to draw shapes, see what it says. Draw shapes. Okay, draw shapes is there. Great, so we say draw elements here. So it looks like all we do is we draw the elements here. So when I animate a line, what do I do? One second, let me go into VI source distributions. And let me go down to test animation. And let's see, that's key. I want to do the function. I literally just call draw shapes. It's amazing how large the Vim plugin ecosystem is. Well, yeah, Vim is one of those text editors that like many people really, really like. So it makes sense that there's a lot of stuff about it. Wait, how is it supposed to be an underdog editor? Like, it is the editor. It's, if you need a terminal-based editor, most likely it's going to be Vim, you know? I'd argue I know very few people who would use like Nano or Pico or something like this when they could use Vim, you know? Okay, here's the draw shape command. So let me go through and let me figure this guy out. So we have animate line, which is fine, but the question is, when do I call this animation? Chrono double time step. Yeah, when do I call this animation? I give it keyframes, and then it looks like I just draw the shapes and it all works okay, but I don't think that's how this goes, you know? SE chrono total time, current time. Total time, move vertex. Well, like, I'm perfectly happy using Vim and all the while my PHP colleagues are trying to force me to use PHP Storm. Maybe. I guess it depends on where you're from, too. Like, if you're, or what you're working on, right? Because there's certain systems that you need a dedicated IDE to work with, and you can use Vim bindings and stuff like this, but it's not really Vim, you know? So it kind of depends on what you're working with, I'm fairly certain. Okay, so what I need to do now is I need to figure out, here's my test animation function. So I need to figure out where exactly I do the animation, right? So I can add in keyframes. That's okay. That's not a big deal. The issue is I want to figure out how I know to animate something. You know what I mean? If I were developing Java code, I'd use IntelliJ IDEA. Could be. Yeah, I know a lot of people use this type of stuff. Let's go to animate line. Let's see where else we call this. Case line, case circle. Okay, so here we have draw shapes, and we say if par.current time is greater than par.shapes start time, par.current time is less than par.shapes end time. Okay, so this is the start and end time of the drawing. So now I need another if statement in here that says if, let's see, if par.current time, where are we? Time is greater than, yeah, okay. Greater than par.color keyframes. Let's do keyframes of color index and do it here. Par.current time. How do I do this? Somebody can't come to terms with editor modes. I type text, no text appears, stuff gets deleted. By editor modes, you mean VI editor modes. Yeah, it's fair enough. Like, you get used to it after a while, but it's hard to do at the start. I have Xdebug and PHP CLI extensions, which extends the default error login provided by PHP. Okay, so how about we say, Okay, we have to find some way to show what the current color should be, right? And then we should change, so this way we don't call this function every time step. So let's go into vi include, and let's do gl setup.h. So the idea here is we have some sort of shape, and this shape should have a color associated with it, but it doesn't necessarily. Yeah, it doesn't seem to have a color associated with it. Oh, because the color is already in VAO. Good, okay, fine. So what we need to do then is we need to find the shape's color. That's something we need to do. And then we should return back a GL and vec3 for that. And then we should be able to figure out what color it's supposed to be and go from there. So basically we have if par.currentTime is greater than color keyframes color index, and par.currentTime is less than par.color keyframes of color index plus 1. Then we go in here and we do something. Okay, so this means we're in between two color keyframes, and in here we'll just go ahead and add some color keyframes in here. So we'll say color keyframe. Oh, let's put it where the ints are. Int color keyframe. Oh, I'm gonna call it color index equals 0. And basically what we're gonna do here is we're gonna say color keyframes, and we'll say color keyframes. Oh, this is actually gonna be a pain, isn't it? What I want here is basically, here, let me show you what I want. Page, new page before. What I want is, basically with time, I want, here's your timeline, a number of times, 1, 2, 3, 4, 5, 6, 7, so on and so forth, that we will draw keyframes with. Yes, what's up, Slayer Darth? I can now echo error messages with my Vim plugin. That's quite cool. Man, I really think I should do something on Vim. Like, I really like it a lot. Or VI. Something on VI, because VI I think we could cover in a single video. It's nearly impossible to cover all the Vim plugins. But we could cover VI, and then we could do another video on Vim afterwards. So VI first, then Vim. This way you can kind of, you can do the easy stuff first, VI, and then you can move into the stuff that's quite difficult and in my opinion hard to grasp. So like the plugins and stuff like this. That I know make your life a lot easier and make them very, very powerful text editor, but at the same time I feel like are quite difficult. When I published the non-crappy code, fair enough. I was using C expression before. But echo error seems much cleaner. Yeah, it could be. Okay, so we want these different keyframes. So how about we do this? We say how about we pop over here and we say if par.color keyframes par.color keyframes .size is greater than 0. Okay, so we go in here if we do that, but I already have it installed. Then we say okay, if we are greater than we have some sort of int color index. So this color index would be 0 for the 0th element, and we say if we are greater than the current that color index, something like this. So this means first of all we have more than one, or we have at least one color keyframe that we need to change with time, and then we say par.currentTime par.color keyframe. If we're larger than this keyframe, we will change the color according to the current color index. Yeah, okay, this should do it. So we'll say if we're larger than color keyframes of color index, yeah, this should do it, I think. So let's do I here D $, oh sorry, D $, and then DD. Okay, good. So now we have that all done, and let's go down here, and let's say, what we want to do is change the color, so we'll do change color of the shape param par. Oh, actually, what do we have here? Switch par.shapes It's not par, it's shape. I don't know if I can. No, yes, that does something different. Okay. So let's see. Change color. Does it do the same thing in Vim? Let me open up Vim. Hello. How are you? Change that to a question mark. Oh, that's interesting. Capital D does something different in VI and Vim. Huh. Okay. Yeah, so C capital does nothing. This is what C capital does if I keep pressing it, which I probably should not have done. D $, current time. I just realized something. So basically we have the par.shapes that size is greater than 0 for size T. If par.current time. Oh, I see what I'm doing wrong. It should be par.shapes of I dot color keyframes. It should be par.shapes of I dot current time. Oh no, par.current time was correct. And it should be greater than. Man, I'm really screwing this guy up. Par.shapes of I dot color keyframes. Let's see, color keyframe of color. What do I call it? Color index. There, got it. Is U undo in VI? Yes, U undoes, but it only does, so it will undo once, and then if you press U again, it undoes the undo. So it's different than Vim in that if you keep pressing U, it will continually undo. Here you can only undo once. So, which is fine by me because if I accidentally undo and undo, it's kind of easier. I know there's a way to redo in Vim, but I don't know what it is. It's like Control L or something like that. It's not intuitive. Okay, so I want to change color of par.shapes of I to whatever the color we wanted to turn into. So this is going to be. We have the color keyframe. Yeah, Control R. There it is. And then we want, I guess, colors of I is what we want then. So these are going to be the colors that we can turn into. So we're going to do std vector of glm vec3, and we're going to call this colors. And this should do it. So this means that we have all the colors, and this should be of color index actually. Par shapes I should be color of color index. That should do it. Control R for redo. Thanks, Miniman. Keyframe or keyframes? You're right. Appreciate it. Let's go over here. Let's make that. Quit. Rain quit. Make that. See how it goes. Colors. Color index. Color index was not declared in the scope. Make clean. Make. I don't know why I just did that because I feel like it didn't really help. Give it a second. Watching this stream on a phone is a pain. Yeah, I'm sorry about that. There's only so much I can do, right? Because I need so much text on screen to get anything done at all. VI include GL setup.h. Let's see. I called it colors. Yep, definitely called it colors. Called it color index. Called it color index. Shape. Oh, okay, that's fair enough. It should be bar.shapes of I dot colors, and these should be. Oh man, that's such a pain. Par.shapes of I dot color index. So I guess we need to pop this down to the next line. Ugh, it's really a big pain. Yeah, it's a huge pain. Okay, par.shapes color index. Yeah, okay. Right here, go over here, right quit, make that. Color index, that's because this guy needs to be. Man, this is such a pain. Okay. Pop this down to the next line. And let's do par.shapes of I dot color index. And make that. In a hotel bed, laptop charger doesn't reach here. Don't worry about it, man. I appreciate you being here anyway. Okay, good. So that seems to make just fine. So this means that we should be able to change the color appropriately. And basically we're checking to make sure the color keyframe size is greater than 0. So we have a color keyframe, and then we go from there. And then the last thing we need to do is say par.shapes of i.colorIndex ++. Make that, and that should be okay. So now that we have this done, I think all we need to do is set it so we have some sort of time frame to change the color with, and it should, in principle, work. Okay, so let's try this. Let's go into VI source distributions, pop down here, and here is the case that we have been working on here. So what I want to do is flip a like draw something that's originally white or purple or something like that, and change the color to something at some time frame. So what I need to do then is, let's see, add keyframes. I need an add color keyframe. So where's add keyframe? Here. So I basically want to grab this guy. So YGP, add color keyframe. Yep, okay, fine, that's how it goes. Shape, par, shape, start time, and we're just going to change this to time. And this is going to be here. Okay, time is going to be always in seconds. So what we want is start offset. I think we still need that, end offset. Good, okay. But we don't need end offset anymore. And start time, we don't need that anymore. So we're going to say shape dot par, wait. I'm missing something up. We have a start time and end time plus start offset. Okay, so this should just be time times 1,000 here. And then we have par.start time, which we definitely need here. Yeah, okay, plus start offset. So what we then want is this to be changed to time offset. 1 second down here, time offset. And we're going to say shape dot color keyframes dot pushback pushback par.start time here, and that should do that. And now we need to push back the color, so we're going to do shape dot colors dot pushback, and we're going to push back the color we want, which will be here. So we'll say, oh, it should just be color. And let's go in here and let's add glambvec3 color. 3 color. Okay, add an ampersand and we should be good to go. Okay, so now we have that. Add color keyframe should be okay. So now what we need to do is add this to our include file for this particular directory. So go into vi include, shape functions. Oh, vi include. Do I not have a shape functions? There we go. G, and add keyframes here, paste it there. Yep. Right, dd, right and quit. Over here, make that. Go into VI source. Node was not declared in the scope. Root was not declared in the scope. Okay, well, see what's wrong here. Expect initially after struct node. Okay. Include shape functions G. Add color keyframes. Right and quit. Oh, sorry. Make. I was thinking about. I've been wanting to make a shirt at some point with like a pocket. You know, it's just like a button-down shirt with a pocket, and on the pocket it just has like, instead of any regular like symbol or something, it just says :WQ. Like that's it. It's just a very simple shirt that has like the brand is just :WQ. And I kind of just wanted a whole bunch of like nerdy shirts made from like with the brand :WQ, and that's what I wanted. I've been wanting that for some time. I just haven't really had the time to really hash out the idea. So let's go into source distributions, pop down here, and what we want to do is add a simple color keyframe. So add color keyframe, and what we're going to do is read in par and par.shapes of, let's do 3. Why not? Just a random number. We're going to have a color, so let's say new color, glm vec3, new color. And again, it's going to be just like last time. It's going to be equal to 1 or 0, 1, 0. Good. And here we're going to say color. Color. And then we say the time, which we're going to say is 1. Yeah, 1. And let's make that. I always use :WQ, even though I know that :X is the same thing. It's habit, but I can't, it's habit, I can't overwrite. Ha, right? Yeah, I get it. Okay. It should be new color. U. New color. Yeah, okay, so to be fair, what's your problem now? Add color keyframe was not declared in the scope. VI source, include shape functions, pop down here, add color keyframes, looks like it's there, VI source, distributions, shape functions is totally there, right, make, clean, make. Hey Slayer what's up? I've said that like 4 times this episode. Add color keyframe. What did I call it? par.shapes 3. New color 1. Quit. Shape functions G. Add color keyframes. Oh. Oh. I was wondering why one of my lists in my Vim plugin was empty, and I was getting an input from executing a shell command. Turns out I'm omitting a redirection operator. Huh. Yep, I forgot S, but let me actually go in here and change this to singular because we are adding only a singular keyframe. So let's go into VI source, distributions, or shape functions, and pop down here. Tell me how to use your plugin already. Okay, write and quit, make that. Give it a second to do its thing, and we should be able to change the color with time. Okay. And now we'll run SciVL. 1 second. Where is it? I know it's here somewhere. There it is. Ah, good. Turn green. Let's try it again. All white, 1 turns green. Fantastic. Great, so now we should quite simply be able to go through and color all the dots an appropriate color with whatever keyframes we want. One last thing we need to do though is source find color. So we have move vertex location. So let me just go down here and do glm vec3, 3, and let's say vertex color, and we want to do shape ampersand shape sh, and we're going to do int id. Fine, fair enough. So it's just going to find the color of a single index, but that's okay. We're going to say glm vec3 what am I doing? vec3 color. Oh, come on, I needed a C and I couldn't come up with a C. vec3 color is going to be equal to, and it should just be basically this guy, just with an offset. So let's just go down here, paste it, 1, 2, 3, 4, 1, 2, 3, 4, there we go, and then we add an offset in here, so it's going to be plus 3, plus 4, and then plus 5. And then we go down here and we return color. Done. Why are you writing your own tree visualizer? Okay, so the idea here is that we are doing, what am I doing? Welcome to my daily job. What I'm doing right here is I'm drawing a basic way to show how to do breadth and depth first search, which are the next algorithms we're covering in the Arcane algorithm archive. So last week we did the relay algorithm. This week we're going to do tree traversal. So again, depth first search and breadth first search. And we have basically all the functions drawn. We have the ability to draw trees. So I figure, hey, let's keep going, make the ability to visualize the movement of like which nodes we check time after time again, and go from there. So that's the idea. Okay, so we have this. Plus, it's helping out with the scientific visualization library. Right now, the library is just kind of, well, I mean, we can do a lot of things. So like if we run, for example, SciVL-S Fourier, we have the ability to do our Fourier transform example here, which is kind of neat, you know? If we do -s verlay, we have the ability to run our shooting ball demonstration, which kind of sort of works. We can do Pong. We can do a platformer that kind of works. Kind of sort of works. I mean, the guy jumps, but the laser's kind of funky. We can't really figure out how to fix the laser, but that's for another time. I don't know. So it's kind of helping out with the visualization library one step at a time. Let's go into VI include, shape functions, and let's go down here and say function. 1 second. To return color of vertex. Okay, and we're going to do glm vec3 vertex color, and we want to do shape ampersand shape int id, and this should make. Nice platformer, subpar graphics, 7 out of 10. Yeah, okay. To be fair, we weren't really intending to make it. Okay, we don't want to make it a game. However, we had. Let me reiterate this. So let me say it in a different way. It's not necessarily going to be a game. It's not yeah. So basically, World Center. I know I've seen you before, so you know kind of how this works. We do YouTube videos as often as we can, and on these YouTube videos, we always have some sort of visualization. That visualization up to now has been usually in Cairo or something like that, but I want to switch most of the visualizations to doing OpenGL. And so basically we're creating the OpenGL library to do the visualizations here. That's the idea. As far as the platformer is concerned, the idea was at the start, we just want to do something very basic, a simple platformer, but then the idea got kind of crazy at some point, and something that I do want to try out. What we wanted to do was create a genetic algorithm that would generate the level for you as you go through, and you can actually see all of these little U's, basically like these transparent U's that are kind of running forward, and like you as this guy, you're literally just running and jumping, and that's all you can do as is, you know, a normal platformer, right? But you can see the level being designed as you're going through it. You know, that's what I wanted to do. Why not Blender? I'll still probably use Blender for my 3D visualizations. It's just that for two-dimensional visualizations, I've found that Blender is kind of difficult to use. In fact, if you look at the Python script for most of the Blender visualizations, so let me go into, let me just open up a new terminal and just show you what this looks like, because it's really difficult to use. It's, okay, fine. When I say it's really difficult to use, it could be worse. CD projects, Simuleos, and I think I have like a fourth dimension, what did I call it? Visualization probably, and let's do fourth dimension. Okay, and let me just show you the Python script for this. So if we go into vi fourth dimension.py, this thing's 676 lines long, which doesn't seem bad. It's just that the notation is really screwy, and it's all just kind of like Blender specific things. So like these temp mats, you have to know how to use the materials appropriately. You need to know how to use the objects appropriately. Like it's great that you have all this access, but it's just, the code is really hard to use, and it's very difficult to understand from a viewer perspective. So because I did all this live, you know, and I was live coding it, it feels like if I'm going to live code something, let's just do it from scratch, and let's just work on it one step at a time. You know, start simple, do some simple stuff, keep working on the library, make it better and better, and that seemed reasonable. Meanwhile, with Blender, it just seemed like I'm just using a very specific tool. With OpenGL, I feel like I'm using something that is useful for a lot of people, you know? Like for example, this guy right here. So add lines, bpy data curves. Again, I will probably still use this for 3D visualizations. It's just, yeah, that was done with Blender. I'll be honest. And I'm glad you're here. But we don't need 3D visualizations for everything. And I want to start kind of doing my own thing. Plus, with Blender, it takes a very, very long time to do the visualization, and I'd like to do some of these visualizations in real time, so we can actually do like real-time input. So for example, directly after I did, or rather during the time I was doing the color quantization video, the idea was I wanted to use the octree actually for a, how do I put this? I wanted to use the octree for the Barnes Hut algorithm. It's a galaxy simulator. And the octree tree ended up being useful for other things, so I just made the color quantization video because I couldn't figure out how to do it, or do a big 3D visualization of all of these objects in any reasonable amount of time using Blender. That was the issue. So I thought, okay, let's do OpenGL. So then that kind of built into the scientific visualization library. It all kind of worked together. It's just that it kind of, I don't know, it's kind of hit and miss. It all kind of, yeah, you know what I mean? Like, one built into the other. But I'm slowly evolving the tools that I'm using with time. CVC, hey, thanks for coming in. That's your fan. Thanks for coming in. I have finished my coding. You should have finished your coding. I will have finished my coding in like an hour. I still have time. Hey, so thanks for coming in, guys. Let's keep going. So right now I'm going to remove this terminal and commit what we currently have, what we've done so far today. Because currently I think it is working. So if we go into Traverse, here, we have a tree. We can change these colors with time, which I'm very happy about. So let's go from there. So let's go do get status, and let's do get add source star include star. Now let's do get status again, just to make sure I didn't add anything unnecessary, and get commit. I'm adding ability to change colors with time and find color of vertices. Okay, and git push origin master. Oh, beta probably. What branch am I on? Yeah, push origin beta. How far behind is master? Let me check that real quick. And I'm gonna do this in a noobish way because screw it. GitHub. Let's go to Cyviel. Beta. Oh, we're significantly behind. Let me see the last push to master. Looks like coming out unnecessary stuff. How long was this? May 3rd. Oh, wow. Wow, we really need to merge this to master. We'll do that after we finish this visualization. Okay. So what do we have? Cyviel-S traverse. Good. So now all we need to do is go into VI source distributions.cpp, move down here. We have the new color. We don't really need this anymore. What we need now is to modify the tree functions so that we can basically add all the keyframes. So now the depth first search and the breadth first search, you could just do git push u origin beta, and then your local beta branch would track origin beta. You could just do git push u origin beta without the branch specification. Yeah, that's okay. I think this is okay as I have it. I actually kind of like doing git push origin beta every time I do. That way I know which, like, for me personally, it helps me remember what branch I'm on. But maybe it's just because I'm a noob and I'm not used to this type of stuff. Okay, so what am I going to do? Okay, here's what we need. We need additional keys so that when we press either depth first search or breadth first search, I'm just going to make it D and B, we do a depth first or breadth first search, and we add keyframes in appropriately. That's the idea. So we have a current time that we read in. You're a little bit late, but don't worry about it so much. Thanks for coming in. Also, thanks for submitting the tree visualization routine. I think a lot of people found it quite interesting and wrote their own tree visualization, I guess, methods. I'm not going to say algorithms because I don't really... Some of them were just different formulas to use with what we currently have. I just have a prompt set up that displays the branch I'm on when I'm in a Git repo. Yeah, something like this. Yeah. Okay, so I was thinking actually, and this is something maybe I should mention again since more people are here, of doing a specific video on tree visualization, like making trees look good, and that was kind of the idea. So if you guys are interested, we could spend some more time, like maybe another week, make another algorithm archive video on just tree visualization and stuff like that. Where am I? What am I doing? I want to go down to key. Where are we? Here it is. Good. So I want to do SDLK. Let's just grab these guys, yank 3 yank, and let's paste it here, and paste it again here. And we're going to say, well, that was a waste of time. Wait, learned how to resolve merge conflicts using vimdiff the other day. Wait, what was the... Oh, not for merging. So we're going to do, for depth first search, we'll do D, and for breadth first search, we'll do B. And the idea here is that par.end does not equal 1, definitely not, and instead we just perform a depth first search and a breadth first search at this particular time, creating the appropriate color time steps, the color, you know what I mean? So we have all the color keyframes. So now we want to just like do the breadth first search and have all the color keyframes drawn. So here we have these two guys set. So let's go ahead and modify the depth first and breadth first search. So let's go into VI source, and I guess it's going to be an aux functions. Now the question is, what do we need? So we have breadth first search queue, depth first search stack, depth first search recursive. We can use any of these. We'll just use depth first search stack, and we'll go from there. Okay. So we have all these different shapes, and we have all of these different, we have all the different locations and stuff like that. I made some tree drawing pseudocode. Paste bin. Open link. Over here. Yes. I really feel like this is something that maybe we should child and node children. Yeah. Yeah, I think maybe we should spend some specific time on just drawing trees. Because apparently I have trouble with it every time we do it. So it's something that I think maybe we should look into. So use the depth first search stack. And what I think I also want to do here, let me think. We need to have some way, let me see. So we need to read in all the shapes, so par.shapes, and we need to somehow associate the shapes with, somehow associate the shapes that we're working with what we're going through here for all of the different nodes. So we have a root node. Let me think. And we have the shapes there. Okay, so let's go and let's look at the node real quick. So we go up here, play Pong. Oh, it's probably going to be in VI include aux functions. Yes, node. Okay, so we have vector children node. That's okay. GLM vec3 position. That's okay. You probably benefit from having a generic tree. Yeah, so we do. Wait, what do you mean having a generic tree? I'm not sure if I understand. So we have this node. It's obviously generic. But when you say generic tree, do you mean just like all these functions are like, I think decently generic, unless I'm missing something. Okay, so we have node here. And what we want then is for each of these guys to also have a corresponding shape, I think. So let's do, yeah, so let's do shape. And I want to do shape here, I think. One second. I want to, I need to think about this. I want to make it so that each of these points to a particular object in par.shapes, so that we can kind of relate the two. For one, they can't really store any data. Okay, so maybe I don't know what you mean by general tree. Like, I don't know what you want in the tree. Yeah, okay, let me think. Yeah, so obviously the issue is here, and this is the same issue we ran into last time, but we solved it in kind of a cheatsy way, so now we have to solve it in a non-cheatsy way. But going back to the list of things that we need to get done today, up, we have add in time stats, done. This one is trivial. We can do this one relatively straightforwardly. In fact, let's do that one now, and then come back to this next. We need to add buttons to depth first search and breadth first search. That's what we're on right now. Wait, where are you? Okay, here we are. Basically, the problem is we have par.shapes. That's not how you spell shapes. Shapes. And this is some sort of vector. And we have a tree. However, this tree, each of these nodes needs to correspond with some sort of point here, right? And that's the idea. I need to find some way to correspond these two guys. It's just going to be some bit of pointer logic, I'm pretty sure. But for now, let's work on stuff that I know I can cover, and then we'll cover the other stuff in just a bit. So what I need to do now is animate the drawing of the tree. Let's do that, because this also will bring up some discussion, I'm pretty sure. Or at least I'll discuss it with myself. Okay, also let me get some water, because I'm kind of thirsty. Again, guys, if you guys have any comments, questions, concerns, feel free to let me know in the chat. Okay, so, it should be, I think, in create tree is what we need to do this in. So I think in create tree, we need to add the keyframes associated with the drawing of all the objects and things like that. The problem is create tree creates the tree recursively. So what we need then is, okay, I know what we need then. So let's go into vi source and aux functions. Okay, now this call to create the tree is incredibly long and annoying right now. I know that, and I apologize for that. But what we need then is another guy. I think another another, how do I put this? Another, I don't know what it's called. What are these variable? There we go. That's what I was looking for. So let's do double time. Okay. And double time will be the variable in which we use to say what time the next object is going to draw. So let's do write and quit. And let's do, what do we want here? Source, include aux functions. Yes, that's what I want. Pop down here and add in double time. Double time. Okay. Oh, that was in all caps. My apologies. Add in a comma and change these to all lowercase. Good. Okay. Still in caps. Write and quit. Got it. Okay, so now let's go into source aux functions. Let's go into create tree. And let's see what we have. Okay, so now what we need to do is every time we create an object, what we need to do is add keyframes to those objects. So create circle is here, and we need to add in, is create, no, it's not doing anything. Oh, well, we're reading in param par. But we need par for par.pushback, par.positions.pushback root.position. Actually, am I using par for anything? You might be right. Maybe we don't have to read in par here. Root ID, root.position. Next, par.positions.pushback. Yeah, we might not need par here, because we probably don't need this guy. Let's go ahead and comment this out. And let's go down here and add in create tree. But what I want to do is create tree with time. Right, quit. Go in. The song is playing right now will be Josh Woodward Anchor is what it's called, from his Ashes album. It's all of the music is going to be available joshwoodward.com or something like that. Josh Woodward here. So this is the music I'm playing. I'm just playing this guy's music because it's Creative Commons. I like the guy, so that's where all the music would be. Okay, then I want. What was I doing? 1 second. I was doing. Oh, VI source distributions. And let's go down to create tree. And let's just change this so that it has a 0 here. Okay. Right quit. Make this. Source aux functions. Root.id. I screwed something up. Error. Expected to initialize it before shape. To 11. Shape circle. What? Oh, how did that happen? Like that. For some reason, yeah, I don't know how that happened. Okay, let's check. Traverse. Yep, still seems fine. So we can actually probably remove par from this. We probably don't need it. But I'm gonna leave it here for now because I feel like I'm forgetting something. So I'll just leave this commented out and leave it there. So we have create circle. What I want to do is add keyframes to the circle. So we're gonna add keyframes, and we want to add keyframes of time and time. Let's do time +1. And then I want to do, I don't know, we'll do keyframes of time, time +1. And then let me see what else we need. So vi source, and we're going to do shape functions. And let's pop down to add keyframes. And it should be, oh, okay, so that might be part of the reason. I need par, shape, circle, start time, end time. Write this, go over here, write quit, make that. And then run the last IVL. Should be this one. Okay, good. All the circles are drawn. So now we just need to do the same thing with lines. Where are the lines? Create tree root. Here should be the line. We're just going to do the same thing with the lines here. Where is it? Add keyframes. Yank. And paste it down here. Go over here, make that. And we're going to do traverse. Oh, the lines did not work. Oh, that's because I need to do lines. Make that. Okay, we're going to do SIVL S traverse. Okay, there we go. So we animated the drawing. We can change how this works. Just let's do that now. So we'll say par line time +1. So we'll give them all 1 second to draw. And what we want to do then is go in here. We want to do create tree, and then the next time will be time +1. Yep. SIVL traverse. Let's make that. Let's do S traverse. Yeah, I'm okay with this. I think this is kind of neat. Yep, that's how I want to draw the tree. I think that's great. Draws just fine. So now I want to change this to be 0.5. So it draws a little bit faster, and then we can kind of go from there. I realize I probably should have had like some sort of time parameter that we read in, but we have so many parameters to be read in here. Make that. We'll kind of leave this for now. Traverse. Yep. Okay, that's cool. I like that tree. Good enough. Okay, so now we have to go back to what we had before. We have the ability to draw our tree. That's great. We have the ability to change colors with time. That's also great. Now we need some way to relate every node to its position in par.shapes of I or whatever. So like each node, right, has a visual object that represents its position, right? Anim speed to be in the header file. Yeah, we could have something like that. I like to kind of stay away from global variables. Let's see, we have double time, which is the start time. We could just have another draw speed in here. I mean, it's just this function call is really annoying. So it's numero -1. It's a really annoying function call. There's no way I'm going to remember this function call. Yeah, let's get back to it in a bit. So for now we have something that's working. We'll get back to it in a bit. Yeah, I think for this visualization it'll be okay. Later on we'll probably want to modify it a little bit. Okay, so now the question is how do we relate each of these guys to those guys? And I think the best way to do that is to So let's see, we go through. Oh, well we can define each of these guys with a particular index. Yeah, we could. We could define each of these guys with a particular index. If each of the nodes have a specific ID associated with them, then we can go through and we can just say, okay, well, we now need to just find the element with that ID in par.shapes, if that makes sense. Like, you see what I'm saying? Like, we have like 1, 2, 3, 4 or something like that here. So each of these nodes has like a 1, 2, 3, 4, 5, 6, 7 or something like that. And each of these guys is obviously 0, 1, 2, 3, 4, 5, 6, 7 or whatever. So what we can do is we can just like relate each of those numbers to the numbers in the numbers in par.shapes. That's one way to do it, but I still feel it's kind of, I don't know, I feel like we're missing something. Because then if we do breadth first search or depth first search, we're going to be going through these guys slightly differently. So we need... Oh, maybe it's okay. Yeah, maybe it's okay because we created in a depth first order. So if we read in... Yeah, okay, let's try it. So what I want to do then is the following. I want to say... int row number, int child number, int offset x, double offset x. Are we using offset x? Yes, we are using offset x. Max row, double radius. Ah, man, this is so annoying. Okay, so we have color here, so let's go ahead and add in another guy here, which is going to be int ID. There we go. Because that's how we have to do it. And we could also read in speed. Yeah. Okay, well, let's just go through here and let's read an ID. So we're gonna go, just to make everything okay, let's say root.id is equal to ID. Here. And we're gonna go down here and say, what is it? It's max row radius. Right after radius, it should be ID here. And what I want to do is output the IDs here. So let's do root.id. And we're gonna do std cout root, come on, .id, new line. And they should all be zeros to start, because shouldn't the node know its ID? Yeah, well, we have an ID, but right now the ID was just set to be the row number. We didn't really go through this appropriately. So, yeah. Yeah, okay. Anyway, we can do it this way. I think this way will work. And we'll kind of think about it from there. So then we want to do right quit. And we want to go in distributions and we're going to do create tree here. And we want to add in ID after radius. And the ID for the first guy is going to be 0. Go over here and make that. I think it should make, unless I forgot something. 0 from int, oh, I know what I forgot. vi include aux functions. Let's pop down here and add that in there. So we want to do double radius and we want to do int ID. The way you can do depth first, it's called the display code, using the visited node's ID. Yeah, that's exactly what we're doing. So now we have to establish each individual ID. So that's what we're working on right now. Sorry if I didn't make that clear. We are establishing an ID that is in the appropriate order so that when we go through the parameter set, we can basically just do, this is 1, 2, 3, 4. So the algorithm is driving the visualization, rather than the visualization implementing the algorithm. Yeah, so that's exactly what we're doing. So let's do traverse just to make sure it works. Works just fine. Good. And all the IDs are 0. So now let's go through and set the aux functions. Gee. I'm removing my ifs, and now I can't keep track of all the ifs and ifs. I'm really sorry. Good luck. Okay, so we're going to go in here, and we're going to define the ID. So the ID is whatever ID we're reading in. And then we're going to go through here, and we're going to say ID. It's not going to be ID plus 1. So we need to create a new ID, which we'll read in here. So we'll say new ID. New ID. Here. And we need to go in here and define int new ID. Somewhere. Let's just do it here. Int new ID. There. And so now we define the new ID. So the new ID is going to be equal to something a little bit weird, I think. So we're going to go in here, we're going to say new ID. Okay, we could say the new ID is going to be equal to ID plus I, right? But this is not going to work, I don't think, because we make that and we run it. You'll see that we are going to have the same number multiple times, right? So it's 0, 0, 0, 1, 2, 1, 1, 2, 3. We need to basically go through and work from there. So what we know is the number of nodes. So let's go in here and let's go into VI source. And I want to do source distributions. And I want to look for node num. Here. Okay, so we know the number of nodes in our tree, right? So the idea then is it's going to be ID plus I plus all the subtrees. So let's go down here. So ID times, and this is going to be power. And what do we have to read in? We have numchild. Good, so I think we have everything. So let's do numchild. I was really bad at the notation here. And we want row num. And then we want to do -1 over row num. Let's remove that. Right quit. Over here. Right quit. Make. Let's see what happens. Row num. I guess it's num row. VI source. Aux functions. Here. G. And let's pop up here. And what do we have? Yeah. Wait. No. Row num. Yeah, it's num row. I don't know why I'm doing so bad with notation here. I just continually flip these guys around. I'm gonna have to fix that at some point. I say that about everything. Row. Write this, go over here, make that. And let's see how this goes. Need a semicolon. Power, that's because I forgot a parentheses here. And yeah, this should be okay. Make that. Let's do Cyviel. Okay, 000244468881 Okay, it's not quite what I was expecting. Okay, so the idea here is that this provides us. Let's do num row -1 again. Make that. The idea. I'm sorry about that. Okay, here is the idea. Page, new page before. The way depth first search works, right, is we have element 1, 2, 3. I'm just going to do a binary tree for now. Here, 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 and here. And the idea is, this is element 0. This will be element 1, which is 0 plus 1. This, though, is not element 2. This is going to be element, let's see, 1, 2, 3, 4, right? So it's going to be element 1, plus this entire tree behind it, right? So we're going to add this entire tree to this guy. So all the elements in this tree are going to be added here. So we add all these elements here, and then so on and so forth, right? So we need to add all these trees from there. Fact about notation. Let me take a look at that. Sorry about that. Here, open link. What do we have? Programmers always use descriptive variable names. Mathematicians, single letter variable names, always ideally from obscure dead alphabets. Yep, that is true. Single letter variable names drive me nuts when I'm doing a lot of programming. So we want I times power of numchild. So let's see, how many children do we have? So this is going to be power of 3. Number of row. So this is, oh, that's because num row should be, let's see, it should be max row minus num row -1. And it should be max row minus num row, something like this. Make that. There's an underscore. Make that. And let me see, what did I screw up this time? Expected 240. Obviously that's an issue, but where is the issue? Oh, I think I have an extra. Max row minus. I think I have an extra -1 in there. No, I don't. Power of that. Wait. Oh, should be power of numchild, max row minus num row -1. Make that. Oh, you'll see how this goes. Do Cyviel traverse. Okay, well, those are all unestablished. That's all wrong. Okay, so this means I'm doing something stupid. We have the current ID plus I times power of numchild plus max row minus num row. What I want is to give these guys each an individual ID, right? I want it to be 0, 1, 2, 3, 4, so on and so forth. So the new ID will be ID plus I times power of numchild divided by max row minus num row minus 1. Let's remove the minus 1. Might not do anything. Nope. Okay, that did nothing. Okay, so let's go through here. New page before. And let's try to figure this guy out. I apologize that this might seem kind of scattered. So we have this. We have all the trees under it, right? Okay. So to find the number of elements in a tree, right? It's going to be the number of children. So we'll say num child. So num children. Let me look at the formula one more time. It will be, I'm looking for, I don't know what I'm looking for now. Node num, I think. Yep, okay. So it's going to be children raised to the row number plus 1 minus 1. Child raised to the row number. So number row plus 1 and then minus 1 here. And I think this is going to be multiplied by, divide by row number. Okay, so I did plus 1. Maybe I should do plus 1 there too. So what is our number of rows here? So we have a max number of rows here, which is going to be the maximum elements in our list. And so here is going to be, it starts at 3, then it goes to 2. Okay, so this is going to be 2, but we want 1. Yeah, so I think I have it right. I think I just have to add 1 instead of subtract 1 or something like this. And then we'll take a look at it one more time. So let's go here. Max row minus num row plus 1. And then let's also go down here and add a... Oh, maybe I don't need a plus 1 there. Yeah, it doesn't look like I need a plus 1 there. So let's do make. One second. SciVLS. Dang it, why is it all uninitialized? New ID is equal to ID plus I times power of numchild. Why? Why would this... It should at least be 0, you would think. So power of numchild divided by, or times raised to, there we go. Max row minus num row plus 1 minus 1. Max row minus num row. Okay, so if max row is 3, so there's 3 rows here, and number row is 2 because we're counting down from 3, so it's 3, 2, 1, 0, then it should be that we have 3 minus 3, so it's divided by 0. Well, that would be the problem there. So let's just do divide by number of rows left. Oh, wait. Maybe it should just be num row here. I'm sorry, I'm confusing myself, but I think something like this maybe. Make, which I think we had before, but I'm fairly certain it's actually correct. 0, 0, 0, 8, 16. How many elements do we have here? 1, 2, 3, 4, plus 9. This should be a total of 13 elements. Yeah, that's clearly not right. How about just num row? And num row minus 1. Make that. Yep, okay, this is I'm doing something stupid here. Go here, make that. I'm gonna have to take a step back and figure this guy out. So let's go into SciVLS Traverse. 2, 4, 4, 8, 12. Oh, actually, wait. This one's not so bad. If I just add a plus 1 in here, we'll do I plus 1. And we will make that. Sorry. Traverse. Hup. Sorry for the sneezing, guys. My bad. Okay, I'm gonna have to take a step back and figure this one out. Sorry about that, guys. So I think I'm gonna go ahead and close the stream here. I realized we're ending a little bit early, but that's okay. Basically, all we need to do is figure out a unique ID for each of these nodes, and then we can read that into the params, or the parameters.shape, or whatever it's called, and then we can go from there. I can probably figure this out on my own. I need to think about it on my own time outside of stream. So thanks guys so much for coming in. I'm probably just gonna go ahead and end the stream here. The idea is that we get the IDs associated, then we do the depth first search and breadth first search. Once we have that done, it should be relatively straightforward to go from there. Like, I honestly think we are pretty easy. It should be pretty easy to go from there. Row -1 times children plus child. Yeah, but we don't have plus child. So, well, okay, we can try this. Let's see. So it's gonna be ID and what it was before. Row -1. Row -1 plus child. Yeah, okay. Well, let's see. Num row -1 times num children plus child. And let's add a guy here. Make that. Add here. Make that. What am I doing wrong here? Num row -1. Num for operator plus. What? Int a node. What? New ID. Oh, num child. Make that. Let's see what we got. 6, 9, 9, 9, 6, 9. Lots of 6s and 9s. Okay, I'm gonna take a step back, figure this out. I'll be back tomorrow, and I will have the solution up for you guys and ready to go. Hopefully tomorrow we'll get the visualization of depth first and breadth first search done, and then we can just move directly into the writing of the Arcane algorithm archive for these two algorithms, and that will be done either end of the day tomorrow, start of the day Saturday, that type of thing. So I'll stream on Saturday. Let's see, what else do I need to do? Outside of that, I think we are pretty good to go. So thanks guys so much for coming in. Have a great day, night, afternoon, morning, evening, whatever time it happens to be your time. Yep, toodles, demo applause, and I will see you guys next time. Thanks guys so much for coming in. Apologize again for ending a little bit early, but I will see you guys next time. Bye guys.